Okay, so let's get started then. So first of all, thank you everyone for joining. This is our last technical session for this year, and this is a really special one because now we're going to compile it and show you everything that's happening with Five Labs and infrastructure, and also on software porting to RISC-V. Today we have three presenters. We have Greg Stirling from RISC-V International. We have Bruno from Jenkins Project, and we have Ali from 10x Engineer. So they're going to cover specific topics today. Greg is going to talk about the labs, RISC-V labs. Ali is going to talk about the 10x Cloud V, and Bruno will talk about his work on porting Docker to RISC-V in only 6 days. So without further ado, Greg, you are the first one. Go ahead and get it started.
All right, I'm clicking all the correct buttons, I hope. So, and if you can't see my screen sharing in a second, I will say thumbs up, hopefully. You can see it.
We can see. Yeah, we can see.
Awesome. So yeah, I'm Greg Sterling. I run a few programs for RISC-V International. I run the Dev Boards program. I run the Dev Partners program, and I'm here to talk with you today about the RISC-V Ecosystem Lab Partners. Sorry, there we go. The RISC-V Labs program overall is about trying to get labs that have RISC-V hardware and help get that hardware access out to the community. We're trying to help folks find bugs, whether it's in firmware or operating systems, help people get resources to build, test software, and just be able to get access to it where they may not be able to get it as a hands-on resource. So got a lot of great teams working on this. Specifically as certified lab partners, we've got 10x engineers, ISCAS, and EPCC. They have gone through the program. They've been able to do some presentations. They've gotten the right amount of hardware, and they get the right processes and policies in place to be able to do that. As far as lab candidates, we are continuing to work with the Oregon State University. Their open source labs has a program that they do have hardware available, and they just haven't gone through the process to get certified. And we have just started working with Inchi, is a Chinese lab that we're working with to get hardware. So we have hardware between Pakistan, US, China, and Scotland. And we have two more future labs we're working with, HFUT and Dalian, both universities in China. Still looking for others, so there's plenty of room for anybody that might be interested. And we'll get into what that process looks like. So if you happen to know somebody that has a lab and wants to get involved in RISC-V, please have them reach out. Just a few highlights. The ISCS folks have been doing a lot of work to provide resources to get Linux kernel builds and tests running. We've got EPCC is doing a lot. They're a high performance computing group, and they are doing a lot of performance testing for those environments, whether it's working through different algorithms or other things to just learn how they work. So some like really cool stuff coming out of that space this year. Open source, the OSU, the open source labs, they've been doing a lot of work. They've been working with Debian to get resources together for doing kernel and other Linux tests and builds. This has been a problem we've seen like in a lot of these spaces, is that the Linux vendors don't necessarily always have access to the hardware, or they don't have a direct way to kind of get started. So these labs are providing very important hardware to get it going. And then similarly, 10x engineers, which Ali will be talking about what he's done, but they've been doing a lot of really good work getting GitHub and GitLab runners working for RISC-V to make it available for folks. Broadly, what we've seen has been a lot of people say like, oh, I want to run RISC-V as fast as possible for like their development environment, which usually means getting something set up locally, and then they find out how much work it is to maintain it and get it up and running, and then they say, can I just get a GitHub or GitLab runner that I can just kind of change a config file and get it to work? So a lot of really good work going on in that space. As far as just ways to engage, we've got a website here, riscv.org/riscvlabs, that if you're interested, please go to this site. We've been putting in information to get folks access to the resources. But in general, if you're interested in getting RISC-V hardware, you just need to go join our community. The different labs have their own processes for getting authorization, getting tokens, or passwords and things, so that you can log in and get access to this hardware. They do have SLAs, so we want to make sure people aren't using the hardware to do password cracking or running Bitcoin miners or other things that would just use a lot of resources and not provide any value back to the community. But definitely, if you're looking for a CI environment, or you're looking for operating at scale, like with HPC stuff, definitely reach out. We're happy to help get folks connected and try and help get resources, and try to make sure we're getting the labs connected with the community members that are interested in this software and hardware stack. As far as the slide here, if you happen to know somebody that is looking to join the program, obviously, if you got hardware, we're always looking for folks that are interested to get connected. So to become the criteria we've got the policy written up, but looking for 10 to 20 10 boards or 20 cores, we need to have some sort of a CI environment, just like Jenkins or other things, so that folks can actually see pass fail statistics of whatever they run on the environment. So it's not just just running it manually. Having some web presence, sorry, just so that you have a way to sign up for your accounts, be able to check things, make sure things are working correctly, and understanding what the policies are of the lab. We do run lab meetings every other week. And we have best practices is basically, we're just looking for folks that are interested in a lab to be able to let us know what kinds of things are meaningful for them to check for data. So sometimes we're looking at uptime, sometimes it's metrics of how quick an environment is, or the stability. We're not really pushing for that, because that varies from lab to lab what's important for them. But the important thing is we're just looking for this to help get set up and maintained. For anybody that's interested in any more details, you can reach out to myself. I'm Greg at riscv.org. We also have help@riscv.org if people just have general questions, or if you just want to help give some people guidance to kind of get into the system environment. With that, I will just say, if there's any questions, I am happy to do my best to give some answers.
Looks like we do not have any question at this point.
All right. Well, hey, thank you for your opportunity. I hope some folks are interested in the lab program, and we'd be happy to get you connected in any way that is interesting to you. Thanks so much.
Thank you. Thank you very much, Greg. And now we move the presentation to Ali from 10X Engineers, who is going to show what is a real RISC-V lab and how later you can use that. So Ali, go ahead, please. Looks like Ali got an issue. So let's give him some time to get. Oh. Okay, Ali, go ahead, please.
Yes, sorry about that. Actually, there was some issue in the camera as well as the microphone. I had to refresh. So let me just share my screen. Okay, so first I'm going to introduce myself briefly. So my name is Tariq, and I have been working on RISC-V for last 3 years. And I've been working in the Linux kernel, as well as on the higher abstraction layers, such as Docker, Podman, and LXC containers, as well as the Proxmox. And I have worked with various software community maintainers in the open source too. And there is actually, I have seen that there is actually a lot of area to contribute to many of the things that we see in the open source, which are not actually ported to the RISC-V. And as far as my designation is concerned, I am senior software engineer in the cloud as well as in the firmware for the RISC-V ecosystem. So this is going to be the agenda. So first of all, I will discuss what is the problem in the RISC-V related to the access for the community out there. And then we will see what is available for everyone in the RISC-V CI. And then we will discuss what is special about the Cloud 5 CI. And of course, this is going to be open source, so you can always replicate everything that we do here. And then we will take some questions, or maybe we will take the questions at the end of the presentation. So as we have seen with the legacy ISAs, that if there is no software support or lesser software support, the ISAs is going to fade slowly, and then we will see that the ISA will not be used by everyone in the software community. So software support is important for an ISA to grow, and to grow in from the academic perspective into the industrial perspective. So we've seen that in the past, Itanium, IA64, DEC Alpha, and Transmeta Crusoe, we don't generally see their CI in the GitHub or the GitHub or the GitLab, or maybe many other CIs out there, CI providers out there. So that is one of the reasons these ISAs have deprecated to much extent. But if we want to enable CI, we need specific software already supported for this, so that CI can run. For example, if we want to run GitHub Actions, we need to have the GitHub Actions package ported to the RISC-V. And then if we want to do that, we also need to have the resources in some of the resources in the hardware stack too, because then we need to check if the specific things work on the hardware and how we can port them. And if there are changes coming into the software, how will they perform in the hardware? So basically, there are two options for the RISC-V CI, and these are using either the emulated instances or the hardware instances. So if we use the emulated instances, there is one benefit that we get, and it is easily available. Everyone can use QEMU to emulate RISC-V on x86 machine or AMD 64 machine. But the downside is that emulation is always slower than the real hardware, and then we can never actually evaluate how the software will perform in case of the real hardware, just like RBB 1.0, which is the vector extension in the RISC-V. So if we use the RISC-V hardware, it is faster than the emulated instances, and then we also see the performance of the software on the real hardware, which is not the case for the emulation. And the only downside is that the hardware is not yet widely available for everyone everywhere. For example, you do not see many instances of the RISC-V or any instances of the RISC-V in the GitHub or GitLab GitHub hosted runners or the GitLab hosted runners. So you always have to spin some self-hosted runners, and same is the case for the Circle CI and many other CIs out there. So this is the current state of the RISC-V CI. So Jenkins, GitHub, GitLab, and Bitbucket, as well as the JetBrains, are ported to RISC-V, but these are not provided by the vendors who are actually providing the CI. The main thing is that the package which they provide for self-hosting the runner for the CI is basically open source, and it is ported to RISC-V. So some of them are not open source, but they still work on the RISC-V because the dependencies which they use, for example, Jenkins uses the Java JDK, and when JDK is ported to the RISC-V, Jenkins can work fine. So this is the case right now, and we also see that Circle CI, Travis CI, and Bamboo CI are still not ported to RISC-V. So that brings us to the Cloud 5 CI infrastructure. So basically, it is a platform for testing applications on the RISC-V instances. in the cloud, and it can be emulated or hardware instances, and it provides SSH access as well as the CI on many platforms, and currently it is free of charge, so anyone can come here and use this. And it provides GitHub, GitLab, and as well as the kernel CI, which is used for the evaluation of the firmware on the single board computers, and many other platforms like Jenkins, JetBrains, TeamCity, uh, which work on the hardware as well as the emulated RISC-V instances. So if you need to see further details, you can always visit the landing page and you will see how this works out. So these are some of the instances that we have here, but we always try to add as many instances that as we can. So there are a couple of RBB 1.0 instances, some of the RBGC instances like Star5, Vision 5, 1 and 2. And there is also scalable EM RB1 instance, which you can get for the CA using the Cloud 5. So basically you can you can come to the page and then you can register a CA on the scalable EM RB1, and it is going to be free of cost for now. So this brings us to the GitHub runners. So in case of the GitHub and GitLab runners, they are provided through a separate page, and in both cases they are monitored through Grafana and Prometheus. And the other thing is that there's always a question for security of the CI, which runs on RISC-V for any instances which are self-hosted. So in that case, we have set up a containerized infrastructure for running all the jobs. In case of GitHub, we use Podman containers, and in case of GitLab runners, we use Docker containers to secure every job which runs on the RISC-V instances. And then in case of the GitLab runners, the package is ported to the RISC-V, which is on the official upstream. But in case of the GitHub runners, the official upstream is not yet ported to the RISC-V, so we have manually ported the GitHub upstream package to the RISC-V, which you can see on the GitHub on our fork. And you can always check out the infrastructure that we have set up through GitHub and GitLab using the link which is provided on this page. So you can also set this up if you want to use a fleet of RISC-V instances and use them as the CI runners for GitHub or GitLab. So for the open source software and contributions, we always have we always have a place where we can collaborate and see how we can further develop the RISC-V ecosystem. So for example, the Cloud 5 provides precompiled RISC-V software binaries for many packages on the web page, but this is not an exhaustive list, and there may be some packages which people want to see in this list. So we are always open to adding more packages on our infrastructure. And secondly, as you can see that GitHub Actions packages uses Microsoft.NET, which is not yet fully ported to the RISC-V, and it is basically partially ported to the RISC-V. And so we can always use help in this, and we can always collaborate in this to make .NET better, which can work on the RISC-V without any bugs or crashes. And the Podman container images for GitHub Actions runner can also use better config for more packages and more security. So for example, if someone escapes the container, which is Podman or Docker, how will that affect the host machine, and how will that affect the other jobs running the same machine? So and for all of these collaborations, lastly, we do have a server on which we communicate with each other and see how we can better collaborate in the RISC-V ecosystem. So that was all from my side. I am going to stop the screen sharing. I think we are going to take the questions at the last, right?
Yeah. We only had one question from Pedro, but it's more about how he can get in touch, for instance, with you at Cloud 5 and use that for his startup. And I pointed him that maybe it's better to join the labs meeting where he can meet all the labs and discuss opportunities for collaboration between the lab and the company directly.
Yeah,
So,
sounds good.
Ali, one question. So recently we saw that GitHub is changing their, say, their approach, and maybe is going to charge for hosted runners. I mean, I'm not sure if there's any change on that, but how would you handle that situation if that's the case?
So as I have checked their policy, I have seen that currently they are not still charging for the public repositories. They are charging for the repositories which are private or if they are on the GitHub Enterprise version and not on the main GitHub website.
Okay, that's great. So there's, I mean, as we were talking, there's one question from Tom regarding Cloud 5. If Cloud 5 is suitable for long-term usage in CI.
Yes, it is long for the long-term use, and we are always expanding it with as many instances as we can. And there is also some work going on in the Kubernetes space, because in the current setup, what we have done is that we have tried to set up something like Kubernetes, but using the Ansible and other scripting. So if the Kubernetes supported, it's going to be more robust environment for long-term use. So yes, it is going to be for long-term development.
Okay, so yeah, thank you, Tom, for the question. I think we can move on, and if you have more questions, please add that in the chat so we can ask Ali at the end. Thank you, Ali. Thank you, Ali, for presenting. Our next presenter is Bruno. And Bruno, sorry, but I think I cannot pronounce your surname, so you may need to fix that. Bruno is from Jenkins, and he's going to show and share with us his work with porting Docker to RISC-V in less than 1 week. So Bruno, go ahead.
Yeah, thank you so much. So it's supposed to be pronounced Verachten, but I know it's kind of difficult. So let me just try to find the right display setting and we'll get back to it. Yeah, that should be good now. Just let me know when you can see my screen. Just a second, please. There we go.
We can see your screen.
Yeah, super cool. Thank you. So, and the date on the slide is not right. Just saw it now. Just stupid me. That's okay. Welcome, everyone. Just let me find the right set of things to set up in order to get it to work. There we go. Let's get started. So, Docker 29 was released by me for RISC-V just 6 days after the official x86 ARM64 release. That's the headline, but that's not where I want to start. You see, to understand why this matters, I need to take you back to why Docker became essential for me and how it's been saving me from dependency hell for more than 10 years. I could tell you a story about a younger me 10 years or so ago, having the idea of experimenting with Docker and ARM32, because that's what I had at the time to make my proof of concepts regarding an Android device farm. And frankly, Docker was a lifesaver back then. But once that was done, it was just like magic for me. It unlocked so much potential on these machines. And to this day, Docker is still one of my staples. I really need it on a daily basis. And what Docker does for me and other developers is that it simplifies quite a lot our daily work. Whenever we want to approach a new tool, a new technology, a new stack, we just add Docker to it. 2 years ago, I used Docker Compose to simplify Jenkins tutorials. And with just one command, you had a full Jenkins running, the agent, the controller, ready to compile your Java, Python, Node, Android, whatever. And it just works with one command. And that's the power of Docker. And that's why I need Docker. I want Docker on all the ecosystems I'm dealing with, all the platforms, all the CPUs. I do need Docker everywhere. But RISC-V, that was a problem. Until recently, it was hard for me to get Docker running on RISC-V. Most of all, it was essentially because of using half-baked distros on my RISC-V machines. For example, on my Milk 5 Pioneer based on Fedora 38, the stock kernel provided for the machine was based on Linux 6.1. It ships with a minimal configuration that omits several critical features Docker needs to function. I tried to compile Docker on this machine, but alas, the kernel was missing the following specific subsystems, which are standard on x86 kernels, but often disabled in early RISC-V vendor kernels to reduce the complexity. The network bridging and NAT, for example, the symptoms is that Docker cannot create its default Docker zero bridge network, or the overlay file system, the overlay 2. The symptoms are that Docker fails to create storage layers, or the C group controllers. The symptoms are warnings about unable to find memory controller or C group mount point not found. And on some of the machines with other distros, Docker was just nowhere to be found. That was problematic. And because of my goals for 2025, that was to make RISC-V a first-class citizen for the Jenkins project. You know, we already have lots of different architectures: AMD 64, ARM 64, PPC 64 LE, F319X, and why not RISC-V? And the piece that was missing was Docker. We produce Docker images for Jenkins every single Tuesday, the weekly version, and we supply them with lots of different architectures, but not RISC-V, unfortunately, because we don't have any means to test it on our own machines. Why should we deliver a Docker image that we can't even test? So what changed? 3 things happened that made this possible. First, with the supply of Debian Trixie last August, we now have supported Linux distribution for RISC-V. We have the official packages. You can just, out of the box, if you manage to get your SBC2 boot, to have the right packages. And recently, thanks to the work of the Armbian project and Debian, and of course, thanks to DevBoard program, I was able to install Debian Trixie on a Banal Pi F3, and there even was Docker available. Okay, it was an old version, the 26.1.5, but nonetheless, that was cool. But once I got this working, I was wondering, why should we stay with an old version of Docker? What is necessary now to get Docker up and running or compiling on such a board? And it didn't take much time before knowing, thankfully. Now, you might ask, Debian Trixie already provides Docker 26. Why bother building Docker 29? That's because Docker 29 represents a major architectural shift. The most significant change is that both image storage and container execution now use containerd natively. Previously, Docker maintained parallel implementations, redundant code paths, and this consolidation reduces internal complexity and enables future innovations like lazy pooling or peer-to-peer distributions. And Docker 29 makes containers snapshotter the default storage backend. Image layers move from var-lib docker overlay 2 to var-lib containerd, and for new deployments, this matters, especially if you're managing multiple machines or planning infrastructure as code. And Docker 29 adds experimental NF table support, moving away from IP tables. Major Linux distributions are deprecating IP tables. So this is future proofing. And if you're deploying on your distributions or planning multi-year infrastructure, this matters. For Docker Swarm users, Docker 29 introduces memory swap and memory swappiness flags for finer resource control. And Docker engine has fully migrated to Go modules, improving interoperability, difficult to say, for tools and SDKs consuming Docker APIs. So Docker 29 is just not just a number, it's architectural modernization and future proofing. That's why we target it. Back in the day, 10 years or so ago, Docker wasn't written in Go, but nowadays it is. And fortunately, Go support for RISC-V is mature and solid. So here's the interesting part. Docker uses Docker to build Docker. So on a fresh RISC-V machine, you need some kind of a bootstrap to get started. So I had to build a local Go image first, then use that to build Docker. So the process is cloning the Moby repo to set up the build environment to run the Docker build with the right platform flags and wait about 35 to 40 minutes on the Banana Pi F3. I remember that back in the day with ARM32, I had to find workarounds, fix issues, touch the code. But for RISC-V, let me show you something surprising on next slide. So the build worked, but here's the part that really surprised me. What we did to have to change so that Docker compiles on the machine is just about nothing, zero, zilch. I was expecting some kernel patches, maybe, no. Some architecture-specific code changes, none. Some compiler works around, not needed. The platform hacks, zero. The reality is that Docker compiles out of the box for RISC-V 64. Go's RISC-V support is mature and complete, and the Docker codebase is architecture agnostic. This is a testament to good software design. So what did we actually change? In dockerbake.htl, we added 4 lines to include RISC-V 64 as a build target. In the Docker file, we changed 2 lines to point to our local Go image, and that's it. 6 lines of build configuration and not source code. And this matters because it shows that RISC-V ecosystem is now mature, that the Go language has excellent cross-platform support, that the Docker architecture is clean and portable, and that the barrier to entry is much lower than expected. So the key message is that the real work isn't really patching Docker, it's building the automation pipeline. And if Docker just works, then anyone can do it. And this is why the 6-day turnaround is possible. So Docker compiles with 0 code change. That's great. But a one-time build isn't useful, of course. What happens when Docker 29.1 comes out or v30? I'd have to manually rebuild everything. So after decades of CI/CD and DevOps works, of course, my reflex is always the same, automated. I often joke that my goal is to automate myself out of a job, and I may have succeeded this time. So once Docker compiled on my Banner Pi F3, the next step was obvious. Make it happen automatically every time. The source code is hosted on GitHub. I could use QEMU and Docker BuildX, but I wanted native RISC-V runners. Unfortunately, as we saw with Ali, there is no official GitHub runner for RISC-V yet. So I searched, how do you get a GitHub runner for RISC-V? The answer is Christopher HX Community Runner implementation, which is written in Go, good thing, which made RISC-V support before official GitHub support existed. Of course, I have to mention Cloud5's GitHub RISC-V runner service we saw with Ali Tariq earlier and the 10x engineer team. The Cloud5 provides managed runners for various RISC-V hardware, as we've seen Banner Pi F3, Vision Phi F2, Milk5 Pioneer, Scaleway, EM, RV1, and so on. So for most developers who want to test on RISC-V, Cloud5 is the better choice. Quick registration, no infrastructure management, testing on the RISC-V in minutes. That's exactly the ecosystem service we need. But my use case is niche. Building Docker with Docker has unique bootstrap and permission requirements. Plus the dogfooding aspect. Runners update themselves with the packages they just built. So I needed full control, and most people shouldn't need this level of setup. So in the end, I set up the GitHub workflows that check official Docker releases daily, and when we detect a new Docker CLI or engine release, we automatically compile binaries, build RPMs and Debian packages, and publish them to repositories. So the setup takes about 2 hours with the Ansible playbooks. Docker engine builds takes from 35 to 40 minutes on the Banana Pi F3, and once configured, it runs, of course, unattended, and that's the whole point. Now, let me show you exactly how you can replicate all of this. Everything I've built, of course, is open source and documented in the Banana Pi F3 GitHub Runner repo. So what's included? You have a complete automation kit with an interactive setup.sh script that validates your configuration, tests GitHub connectivity, and orchestrates the entire deployment. We have Ansible playbooks that handle all the infrastructure as code. No manual configuration needed. And you have 7 step-by-step hardware setup guides from unboxing your Banana Pi F3 to having a fully operational runner. The security documentation also exists. It covers SSH hardening, firewall configuration, and best practices. So the setup process takes about 2 hours total. You unbox your Banana Pi F3. That's a SpaceMeet K1 with 8 RISC-V cores and 16 GB of RAM. You install Armbian Debian Trixie. You run the setup.sh script, which asks you a few questions about your GitHub repo you want to automate and the token. And then the Ansible takes over and configures everything automatically. And in the end, your GitHub runner registers itself and you're ready to build. So what do you get? A self-hosted RISC-V GitHub runner with Docker pre-installed and configured. You also get an auto-update mechanism that keeps the runner software current and a dog fooding ready infrastructure, the same setup I used to build Docker itself. So the repo is linked in the slide. You also have the QR code if you want to, and it's MIT license. So it's everything you need to achieve the same 6-day to 1 hour release cadence. It's right there. It's documented. It's automated. So if you have Banana Pi F3 or similar RISC-V hardware, you can have this running by tomorrow. Since then, as it was working, I said, okay, what's missing now? We also had in Debian an old version of Docker Compose. It's by default on Debian Trixie. So I chose the same way of working. And soon enough, I had a working, very recent version of Docker Compose on the RISC-V 64. Then I was also needing Docker BuildX because why not? I also recompiled Docker BuildX on the machine, and also the latest one that I kind of needed was Docker C Agent or Cagent. I have no idea how this is supposed to be pronounced, but it also works. So now in my stack, I have Docker Engine 29, Docker CLI 29, Docker Compose 2.40 something, Docker BuildX 0.19, and Docker C Agent, the very latest version. And all of these pieces of software are built automatically, packaged for Debian and Fedora, and available via GitHub, used as apt and RPM repositories. Now, let's see it in action. So here I'm on my Banana Pi F3. Oh, as you can see, it's running Linux 6.6.99. And I have a version of Docker that I compiled, which is 29.1.3. So the very last one from yesterday or the day before. Now, let me run the script, the demo script that will tell us what's installed on the machine. So this first one is to check if we have Docker 29. We already proved that. Next one is to see if a standard, the Hello World container works on RISC-V is my version of Docker. So it's pulling the image, running the image. Fantastic. We saw that this is working on the machine. Now, the next step is to build a custom RISC-V application in Go. So we have a Docker file. We build the image. Well, it goes fast because it's already cached. That's why. And now that the image has been built, we will just run the application within the Docker container. And it also works. It's as in any other platform. It's as simple as that. Now, we'll try something more difficult, which is Docker Compose, which I recompile on this very same machine. Does Docker Compose will Docker Compose be able to launch several Docker services and make them communicate? We'll see that it's building, it's running. A web server is running in Docker Compose. That's perfect. It also worked pretty well. Now we're shutting down these 2 services. Hopefully this will work. Yes, indeed. So we showed that the latest version of Docker Compose is now available for RISC-V and working pretty well. The next one is the most complicated one to me, is the multi-platform builds with Docker BuildX. So that's why that's the way that most of the RISC-V images we are finding these days in Docker Hub are built. We use some ARM64, AMD64 with QEMU and Docker BuildX in order to build some RISC-V images. It's not built locally on a native RISC-V machine. And we'll try to do the other way around. We'll try to build a RISC-V image on RISC-V, but also AMD64 image on RISC-V. And let's see if this works. It also works. So I just built a RISC-V and AMD64 image on my RISC-V machine. That's pretty cool. Now, what else? We'll see if Docker 29 uses containerd as proof. Yeah, it also uses the containerd. So the whole test worked. We didn't have any demo effect. That's pretty cool. Let's go back to the slides now. So you should say to yourself, well, this guy looks happy. Is he really? Yes, I am. I'm happy, but also not really. The thing is, it works. That's pretty cool. Maybe nobody else but me is using that, but I'm already happy because it just works. I have a complete, very up-to-date ecosystem working for me. But that's not the biggest thing I want to achieve. What we have to do now is to get accepted by the Docker community itself, or even the Docker project. I went to the Slack channel of the Docker project and said, hey, you know what? I made it. I got the Docker client, Docker BuildX, Docker plugin, C agent to build with my RISC-V 64 ecosystem. And I even supply packages ready to install. It's on a regular basis. It's maintained. So what do you think? We should make that more official. I proved it could work. So what blocks you from doing that on your own? And the response was not the one I was expecting. It was, no, thank you. We don't need that. You know, RISC-V is niche. It's not that much for everyone. It's just for hobbyists, tinkerers, maybe universities. And my response, no, not at all. And my mantra is build it and they will come. So what stops you from building Docker for RISC-V? And then I heard the silence, you know, the crickets, the crows. Nobody answered. That's one major problem for me. What I would like is that distros get a new version of Docker for RISC-V by default. I would also like that the standard script that is supplied by Docker, you know, the script we get with curl, then pipe to bash, works for RISC-V 64. I know it's not secure, but whatever. It's maybe too early for the Docker project. I don't know. But that would prove that it's treated as a first-class citizen, you know? I think the journey is not over yet. But I'm not sitting around waiting for them. We don't have time to talk about Node.js today, but it was also a cakewalk to get Node building on a regular basis on RISC-V. And maybe the Node community will be welcoming enough. So what's next? Continued automation and ecosystem maintenance, expanding to more RISC-V platforms and distributions, working with upstream communities, of course, for official recognition, and building the case that RISC-V is production ready. The journey from release to production took 6 days for the technical work, but getting the community to recognize it as production worthy, that journey continues. But here's the best part. Those first 6 days, that was us still experimenting with GitHub Actions and Docker, figuring out the workflows, debugging the build process. But now that the automation is mature and the pipeline is proven, the 6 days became 1 hour. Thank you.
Thank you very much, Bruno. So that's really impressive. So myself, I have worked on porting Docker to PPC64 lead in the past, so I know how hard it is when you are trying to make things happen and the community does not have access to some resource to validate and test that. So it's interesting. It's an interesting journey and an interesting work. So yeah, thank you very much for that. We have one question in the chat about what RISC-V extensions are required for Docker.
That's a tough question. I think none of them. At least, I don't know. The extensions are not reported correctly, I would say, on the Banana Pi F3 I'm using. Of course, they have the vector extension that helps when it comes to compiling. But I'm not so sure. If you ever have a command that would help me know what I have used. In fact, you got it. I'm not an expert, not at all. I was just a happy tinkerer trying some things and getting things to work, but not because of my talent, just because the ecosystem is mature enough so that it works. I don't know, but if you want to get in touch with me and give me the right comment, because you seem to know more about that than I do, please feel free to do so, and I will do my best to answer.
I believe there's two places to look at. One in the kernel itself and under the version of the Go and what the Go compiler is supporting. So you can maybe take a look on that.
Okay,
and I believe that as we move forward with container, and if you look at the Red Hat, where they're moving from VM management, so at some point for running containers, we may require the H extension for hypervisor, especially if we want to run those more kind of kata containers and things like that that require a little bit of the virtualization layer as part of that. But anyway, that's still a few months ahead or years, we don't know.
Yeah, and I see another question from Tadeusz Meyer. Did you consider becoming a Debian Docker package maintainer? Yes. That's not the path I wanted to have, because I'm not a package manager specialist or whatever. I just wanted to prove that it could be done, so that other people take the lead. But if that's what's needed to get it to the Debian as something official, of course I'll do that.
Any more questions for Bruno or for Greg or for Ali? And this one. There's one on GitHub Actions.
Did you face an issue with GitHub Actions? Because currently on v8.0.101 is supported for RISC-V. I did not get any issue with GitHub Actions. In fact, the Christopher HX software works really, really with that. It's linked to Node.js 20-something, and no. Oh, somebody used my Docker package. Thank you so much, Tom. Made my day.
I will definitely use your Docker package because I am facing a lot of security issues right now with the older versions.
Oh, nice. Okay, great.
Yeah, that's great. So, and Bruno, maybe I'm going to connect you with Megan from our team. So maybe you can write a feature work on the work you did with Docker, because we can amplify that and ensure others can view and use your work, which is a great outcome of what you have done.
I'd be glad to help.
Yep. Yep. So, folks, I'm not sure if you have any more questions. We have time. So if you have questions, please go ahead, put that in the chat. If not, we can thank you all the three presenters, because what you saw today is how things all get connected. So we have Greg managing the labs and providing boards to a lot of people across the world. We have Ali providing a base infrastructure that anyone in the world can use. And then at the end, we have a end user that does have a case and an issue to solve, and with the right resource in hand, was able to manage to get that done. So you see how the RISC-V programs and the community itself can get together to manage to get or advance RISC-V as quick as possible, maybe in less than 6 days in the next one. So if you follow Bruno on social media, you're going to see that every day, basically, he posts some new package or software that he managed to get running RISC-V, which is a kind of impressive amount of work. Yeah, I mean, people ask about slides, so maybe the presenters can share and later can link that to the Bevy event, so you can just grab the slide from for a single location. Okay, so yeah, I would say thank you very much for everyone for joining. This was our last technical session for this year. The recording will be available between today and tomorrow in our RISC-V YouTube channel, and the presentations will be available in Bevy as soon as I get them from the presenters. Again, thank you very much. Happy holidays for those who celebrate, and see you again next year, in January for the next RISC-V technical session. Thank you everyone for joining.
Thank you so much. Bye-bye.
Thanks, Raphael. Bye.
Bye.